progression of disease, progression and pathogenesis. So first, progression of disease. So in the PD Parkinson disease, there is a motor system, and this is due to substantia nigra, neuron loss. There is initial involvement of the motor system. Initial involvement due to the substantia nigra, neuron loss, and this disease progression move to the limbic system. Move to limbic system, and that causes emotional and behavioral change. Behavioral changes also change, and then also affect cortex. So there is leads to dementia with there is a accumulation of Lewy bodies. So it is not a movement disorder. It is not a movement disorder. It is eventually become the multi-system disorder. It's become multi-system disorder. So when we look for the pathogenesis, we discuss three things in the pathogenesis. First, regarding abnormal protein. Then we discuss mitochondrial dysfunction, or power failure. Then we discuss lysosomal failure, or this is also garbage disposal stops. So in the abnormal protein, there is alpha synuclein. So normally it's help to communicate. This alpha synuclein is normally it's help to the nerve communication. But there is in the PD there is alpha synuclein misfolding, and that risks to the stick together and form, and it's misfolding and stick together. One synuclein stick with the other and form Lewy body. It is a protein of misfolded protein. It is a misfolded protein. So this Lewy body is a clump of abnormal protein inside a neuron. Misfolded protein and clump of clump of abnormal protein, clumps inside neurons, neurons, neurons. So it's mainly found in, it's found in substantia nigra, substantia nigra, and brainstem, cortex etc. In the cortex region etc. So it's a spread like pran. This Lewis body is spread like prion, prions. Like if one apple and another is this is a good apple or this is a bad apple, so or infected apple, this infect the other and form is also bad, like that way. If the protein, if one bad protein is there, then make others are also bad, make others are also bad. So this Lewis body travels, and there is some like pesticides and this pesticide also. This if there is this misfolded protein and in the gut, so it's travel through the gut to the vagus nerve, and through the vagus nerve travel up to the brainstem and midbrain and then the cortex. So there is also a gut brain theory or hypothesis to explain link with the pesticide. There is if link with pesticide, this pesticide lead to the forming the Lewis bodies. Now we are moving on the mitochondrial dysfunction. So in the mitochondrial dysfunction there is a gene like pink, PINK1, Parkin and DJ. We have also summary discussion further. So first we discuss in this portion. So a gene like pink1, Parkin and DJ1, this help to the keep to the mitochondria healthy, or make mitochondria healthy. So there is the mutation of this gene, or there, and in the PD there is a mutation of this gene, or there is defective in the gene that lead to the mitochondria damage in PD. And this Parkin, pink and pink1 cannot clean up them. So this mutation, this did not lead to the damage mitochondria to the clean up. It helps in the cleaning. So there is the damaged mitochondria build up, and that leads to the energy failure or stress. And there is the damaged mitochondria and increase or build up, and that due to the cells die, this leads to the cell die due to energy failure and stress. Energy failure and stress. And another one is the lysosomal failure. So this is garbage disposal. If there is the mitochondrial damage, so there is a GBA gene, and it's make enzyme known as enzyme that are glucocerebrosidase. glu- glucose cerebrosidase, and it's help to clear the clear waste protein or misfolded proteins. When it does not work, this gene does not function and this enzyme is not work, doesn't work. If doesn't work, then that leads to the accumulation of or building of the waste protein, like there is a accumulation or increase of protein like alpha synuclein, and there is that neurons get clogged and die. So there is some genetic predisposition or there is some genetic role. So I am going to summarize all the genes, what are the involved and the function and the roles. So there is gene role and what goes wrong. So there is SNCA gene, that's role is produce synuclein, and if there is a mutation go on, then the Levy body formation. So mutation lead to the protein clumping or formation of clump, that lead to the Levy body. Another one is LRRK2, and then LRR2K is the kinase. Role is the function kinase. So overactive, that lead to the toxic to the cell. Overactive lead to toxic to the cell. It's toxic for the cell. There is another Parkin, and this Parkin has role is the ubiquitin kinase, formation of ubiquitin kinase. So if there is a problem that lead to the that cannot take bad mitochondria for the destruction, can't take the bad mitochondria for the destruction. So there is no destruction of the bad mitochondria. And there is a pink one. There is a mitochondrial. It is a mitochondrial sensor. Function is as a sensor. So if that is not working, so there is cannot call for the Parkin for clean off. There is DJ1. So it is antioxidant. So if that is not working, so it cannot protect against oxidative stress. There is a GBA we have already discussed. So it is a lysosomal enzyme, formation of lysosomal enzyme. So it is not forming the enzyme that the bad protein are accumulating, or bad protein cannot kill your protein difficulty in the clearance. So accumulation of alpha synuclein build up. So now we are moving in the cross. We are moving on the cross and the microscopic feature. Cross and microscopy in PD. So in the gross, there is once in the autopsy, when gross features in the autopsy, there is the pallor and paleness due to the pallor in the region of the substantia nigra and locus coeruleus. Due to that, there is the decrease this neuron and dye that is less pigmented due to the because pigmented neuron died. So there is no pigmented neuron or less pigmented neuron that lead to the pallor or paleness. When you look for the microscopy, there is a living body that are pink round structure inside neurons, and that's are dense in center, with the pale halo, dense center with pale halo. Dense center, pale halo. When you look there is a Lewy neuritis. Abnormal protein. There is abnormal protein filled in nerve processes. Then there is a gliosis. In the gliosis, there is a scarring response after death of neurons. There is a scarring going on that is known as gliosis. So beside this, there is some other causes for the Parkinson beside the Parkinson disease. There is a drug like that induce like antipsychotic drugs and that block the dopamine, and also there is like haloperidol. There is toxin like MPTP. This is a illegal drug of morphine or this type of drug heroin, and that lead to the toxin agent and other diseases like multiple system atrophy and PSP etc. disease also cause this type of symptoms. So we have covered from the pathology of robbins regarding the Parkinson disease.